So now in this video we're going to be looking at series LEDs. So here I have brand new, just out of the box I should say, LEDs, and because sometimes when you put too much current through them they don't get as bright afterwards and whatnot. So these are all brand new. I know that none of them have had too much current go through them, but in any case they are in series, as you can see there. So the things we're going to look at, and we're going to get rid of the diagram shortly. The main thing is that the LED voltages stack up. Now, yellow and red, they only drop about 2 volts. So it takes about 2 volts for them to conduct. At very low currents, it's lower, but it's about 2 volts. And it takes about 2 volts for them to conduct, and then they conduct about freely. But that voltage builds up across the LEDs. It drops across every other series component, including the resistor, which sets the current. And so if you got 3 of them in series, each one of them is going to drop about 2 volts, and so you'll have about 6 volts less across the resistor than the power supply. And if you have a 1 kilo ohm resistor, you take that voltage divided by 1,000, so that's in milli, so it will be milliamps. And so if it's 1 volt across the resistor, you'll have 1 milliamp. 2 volts across the resistor after the drops of the LED, then you'll have 2 milliamps, and so on. Not too confusing. Now the green LEDs and the blue LEDs we'll look at, they block more voltage. I should say drop more voltage. They take more voltage to conduct, and thus there's less voltage across the resistor, but you're going to see that the green and the blue LEDs, even though they have less current going through them, because we're going to just use a 1 kilo ohm resistor and to keep the power supply voltage the same, they'll have less current going through them, but they'll be brighter than the red or the yellow LEDs. So they are more efficient. So now we have the power supply here. A couple things. We're working with 15 volts. We have 3 LEDs in series, so again they drop a lot of the voltage, so we can go up with a higher voltage. So that's a 1 kilo ohm resistor, and the output is on. I have current limited to 20 milliamps. All these LEDs have a limit of about 20 milliamps. We cannot exceed that right now. The power supply will stop providing enough voltage to raise it above 20 milliamps. So we know that we are keeping the LED safe. And so we got all 3 lit up there, and so you know that we didn't miss one. There you can see we have 8 milliamps of current. That's the main thing. This is not completely accurate. It's maybe 9 milliamps right there, but it is close enough for this video here. The yellow LEDs, we should see the same current right there, 8 milliamps of current. Now, I haven't tested any of them yet, other than what you just saw. I know that these two are going to have less current through them. The main thing is, though, you can see the yellow and the red were about the same brightness at 8 milliamps. If I go to blue, you can probably tell right there, they're quite a bit brighter. And same with green. Green is quite a bit brighter as well, right there. So even though there's less current going through blue and green, they are a lot brighter. They're more efficient. And so what that means is if we're using a battery, so the battery will have a certain voltage, but with that voltage you're going to get a certain amount of current over time, and 5 milliamps of current will drain the battery over time, a lot less than 8 milliamps of current. So now what we're going to do is look at it with the oscilloscope, and I have the cable there that comes to those alligator clips. I clipped them to these jumpers, which I can move across quite a bit of the board there, as long as they can reach. So I have both the blue LED and the red LEDs with a 1 kilo ohm resistor, and you can probably tell the blue LEDs are brighter, and we looked at before that they had less current going through them, so they're more energy efficient. Now we have a little better of a side-by-side comparison. In the diagram at the beginning, we looked at the voltages across the individual LEDs plus more of them in series. That's kind of how I drew it out. I didn't really cover it all that much though. But in any case, we have the 0 volt reference point as far as the meter is concerned. the black alligator clip, the blue jumper, to ground. Now we're going to go up one spot from there, so one LED. There you can see it's a little less than 2 volts. It would be higher if there's more current flowing. And a little less than 4 when we go across 2 LEDs. And then right now we're in the same spot as the resistor right there. So at the top of the 3 LEDs. So you can see their voltages. The voltages across them stacked up. So we're dealing with 15 volts. And so if we go across this resistor, we can expect 9 volts. But there is only 8 squares right there. 1 volt per square. So what we can do, and before we do that, you can see we got 15 volts. And both LEDs are lit, so the current is higher. Current's not exact though on this. So the numbers may not add up exactly to what we had before. What we can do is change 1 volt per division per square to 2 volts. So now it's 2, 4, 6, 8, 9. There we got 9 volts across a 1 kilo ohm resistor. It looks like it's probably spot on about 9 volts. And so it's actually 9 milliamps of current going through there. Not the 8 that this meter was telling us, but this isn't accurate. A multimeter would have been more accurate. So now let's do the same thing with the blue LEDs really quick, but we're going to put the meter back to 1 volt per division. And so again, ground, we could stay over there, doesn't matter, it's all one connection point. But in case, I'm going to go up one spot above the gray jumper there. Now you can see it's closer to 3 volts. I go up one more spot, about 6 volts, and then now about 9 to where the resistor is. And so we can actually, since it's 9 across there, look across the resistor first. We'll get the voltage because it's less than 8 across the resistor. So we got 1, 2, 3, 4, 5, 6 right there. 6 volts across the 1 kilo ohm resistor. So it should be 6 milliamps of current going through there. We want to look at the voltage across all of the LEDs. Then we want to put that back to ground, and then put this one up to the top of the LEDs right there. And we are blocking 2, 4, 6, 8, and then about 9 across the LEDs. So the voltages across the LEDs and the resistor on one side are opposite of the one over here because the LEDs are blocking more voltage over there. But there's less voltage across the resistor and thus less current. And so that's really about the end of the video. Thanks for sticking around. This may not seem too exciting at first, but these are all really important electrical properties. And the biggest one is that the supply voltage gets split or divided, however you want to say it, between series components. That's always the case. You got the supply voltage, and then the voltage will be broken down between each of the components. The voltage across each component will add up to the supply voltage. That is the important thing. And also we looked at how some components are more efficient than others. You'll get more out of them at a lower current. And especially if you have batteries or something, the less current you use, the longer they last. They'll be more energy efficient. And so everything that we covered here is important for understanding more complex circuits. So thanks for sticking around. But in any case, check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. I put a link down in the description. I'll see you in the next video.